What's up, guys? It's Doo Doo Poker. We're here for another episode, and today we're going to talk about 3-bet pots. And I've always found the best way to learn poker is to think about just one hand at a time. So I'd rather spend 10 minutes on one hand than, 15 minutes on 5 hands, right? Because I really want to understand what's going on. So let's think about this spot. Cutoff opens. I'm going to give us pocket kings in the big blind, okay? This is a hand I played a couple months ago, but it illustrates a lot of important concepts. And really what poker is about is it's about concepts. So I 3-bet and cutoff calls, and the flop comes 9-7-4, okay? So we have pocket kings. Now you'll see here, kings is mixed, which means the EV of betting and checking is the same. So let's say we decide to check, okay? I'm going to give you two scenarios. The first scenario, our opponent bets, okay? Now, we know kings can raise sometimes and can call sometimes, okay? But let's look at MDA for this spot. We know from MDA that they overfold. This is bet 30, folding to check raise, right? We know they overfold to a check raise. So if it's the same EV between raising and calling, then we should just call. Because you always want to play your hands in a way that your opponents do not expect. I've said that before on a different video, but when your opponents read on what you have is not correct, then we're going to gain EV, right? So every time your opponent puts you on a hand and you don't have that hand, they lose value, okay? So that's the first important point. So if they stab here, if you decide to check flop and they stab, you should always be calling, right? But let's say they don't stab. Let's say they check, and the turn is, let's say it's a 2, okay? Now, we see here again, kings is mixed. That means you can bet or check. You can do whatever you want. But let's look at incentives. Do you think if I bet turn after check on the flop, so a delayed C bet on the turn, that cutoff overfolds, underfolds, or GTO defends? Well, let's look at the data. We see from the data that if I bet on the turn after flop goes check, that they're overfolding by at least 10%, as much as 15%. So between 10 and 15%. Okay? So do I want him to fold? No, I don't want him to fold. Right? So that makes me incentivized to check. Let's take a look at, if I do decide to check, how often cutoff stabs on the turn versus a check line. Now, my opponent stabs on the turn after I check flop, he checks back, and then I check turn more than GTO, right? On the high end or more than GTO. So I'm incentivized in 2 data points. I'm incentivized to check because they overstab, and I'm also incentivized to check because if I bet, they overfold, and I have a very strong hand. I don't want him to fold. So we know in a solver it's mixed, but we should pure check because although it's mixed, we're going to lose value by delayed C betting. So it's important to understand this. So whenever you play a hand in a way your opponent expects you to, you're going to lose value. Just to give you an extreme example, let's say you're in a 3-bet pot, right? And you have ace king. Now, what is the most common hand that your opponents will put you on in a 3-bet pot? Ace-king, right? So ace-king loses more value in practice than in theory. Because whenever you have ace-king, your opponents will put you on ace-king, right? So you're going to lose value on ace and king high boards. And whenever you bluff with ace-king, your opponents are going to put you on ace-king and call down more on non-ace or king boards, right? So ace-king loses value in practice compared to theory. So when we have a hand like kings, we know once the flop goes check-check, there's a 10 to 15% overfold on a delayed c-bet. So it's mixed in a solver, so we should take the check line. We also know that they stab more than GTO when check 2 on the turn after a flop goes check-check. So again, we're incentivized to check. So this is a good way that you can use MDA to outperform theory. And I hope you guys learned something in this. And we can combine MDA and theory to do better than what the solver is showing us. All right, guys. Hope you enjoyed that, and I'll see you in the next video.